Welcome to my complete Practical CCNA course. This course is very different to other courses. I'm going to be explaining CCNA topics using physical equipment rather than simulations or emulators. I've heard this story too many times. New person arrives at site. They need to configure a device. And they ask, where is the device? And the customer is shocked because the device is right next to them. And that's because the person has only ever used simulations or online labs and doesn't actually know what devices look like. It's really important that you see what the physical devices actually look like and how they act, rather than just using a simulator or even an emulator like CML. I've spent thousands of dollars collecting various devices to add to this course, and this is only some of them. As an example, here's a Starlink Mini. This really changes the game because you can access the internet using a portable satellite dish like this. This has a built-in router, and I'm going to explain what a router actually is, because you need to know the differences between, say, routers such as these or some of these routers versus what a switch is and what a layer 2 and a layer 3 switch is. You may not understand what those terms are right now, but in this video and in the course, I'm going to explain those topics in a lot of detail, and you're going to configure Cisco routers and switches so that you have the knowledge to pass the CCNA exam, but also have the knowledge to go out there and be successful in your career. Now, Packet Tracer and CML or Cisco modeling labs are fantastic for labs, and you can use those as part of this course, but they cannot simulate physical devices like these fiber optic cables. You need to know the difference between a single mode fiber optic cable and a multi-mode fiber optic cable. Notice the difference in the light shone through these cables. Single mode fiber, if I bend it, you can see the light bleeding through the cable there, but notice the pattern doesn't really change. Whereas with multi-mode fiber, if I bend the cable, the pattern changes. It moves. You need to understand the difference between multi-mode and single mode fiber. Very difficult to understand that and visually see what it does when you're just using an emulator. Now, you may be wondering, why do you need to know about fiber cables? You're actually using them right now. The world is connected using fiber cables under the oceans. So when you're watching a YouTube video, as an example, that information is transmitted across a fiber cable such as these. We also have copper Ethernet cables. So this is a copper Ethernet cable that you've probably seen before. It's using an RJ45 connector at the end here. This uses copper. This is fiber. Data is transmitted through light through these cables, whereas here it uses electricity to transmit data. Now, in the CCNA course, you're going to learn about an Ethernet bridge. Specifically in spanning tree, you're going to learn about something called the spanning tree root bridge. Most people will just show you a picture of a bridge. They will not show you what it actually looks like. So they'll use an icon. And we've actually designed brand new icons for this course. So all the topologies are going to be using a new icon set that we've created. So you'll just see an icon similar to what's on screen at the moment, but you don't know what a bridge actually looks like and how it actually acts. Now, I do get some pushback or flack when I show older devices, but a really important lesson in networking. If you don't understand the past, you won't understand why things act the way they do today. Like, as an example, if you don't know what a bridge is, you wouldn't understand why we have a root bridge rather than a root switch in spanning tree. You wouldn't understand why a switch, and this is a very modern switch, this is a 9200 CX switch, why a modern switch like that is better than a bridge, or even an older switch like this 2950 series switch. Switches are much faster than bridges, but they act in a very similar way. In the very old days, we had interfaces like these. These are serial interfaces, very, very slow. You may still come across them depending where you are in the world. So I'm going to talk about some of the history as we go through this course so that you understand concepts such as a collision domain or broadcast domain. Collision domains were really important when we had hubs. Notice this is a Cisco hub. This is a hub. This is a switch. They're very different. A hub, as an example, works as follows. When traffic arrives in one port, it's repeated out of all the other ports. This is known as a multi-port repeater. Here's an example of a single port repeater. We've only got port 1 and port 2 here. So when traffic arrives in one port, it gets repeated or amplified out of another port. That allows Ethernet to traverse much greater distances. So as an example, with the cables that we tend to use today, UTP cabling, a cable like this as an example, maximum distance is 100 meters. If you wanted to amplify the signal or have the signal go further, you need something that repeats the signal or amplifies the signal. And this is a very basic example of a repeater. Multi-port repeater or hub is a dumb device. It doesn't understand the traffic sent in the network. So when traffic arrives on one port destined to one other device, it's simply replicated or repeated out of all other ports on the device. That means that if you have a collision on any one of these ports, it affects everyone in the topology. Switches work differently to hubs. So in switches, we use what are called MAC addresses or hardware addresses to identify hosts on a network. So when you use your phone as an example to connect to a Wi-Fi network, or you use your computer to connect to a physical Ethernet network, you'll notice that it has what's called a MAC address or media access control address. That is a hardware identifier for a device on a Ethernet network or a Wi-Fi network. Your device will also have an IP address. Here we've got both an IP version 4 as well as an IP version 6 address. In networks today and the internet today, we use IP version 4 or IP version 6. Those are protocols or languages, if you like. Here we're speaking English. Hopefully you can understand what I'm saying because we're speaking the same language. When a phone, as an example, is used to go to YouTube, the language used by the phone to send information into the network and for YouTube to send a video back to the phone is IP version 4 or IP version 6. Now, I've invested thousands of dollars collecting equipment for this course, and this is only some of it. Not only collect equipment that you might never have seen before, such as this Ethernet bridge or the Cisco hub, but I've also collected very modern devices to add to the course, such as this Catalyst 9200L switch. And one of my favorites, the C9200CX switch. I like these small switches, such as the 1000 series switch, because they're quiet and I can run them on my desk without a bunch of fan noise. But I have got bigger switches, such as this one. I've also got a Cisco 8200 router, or what Cisco call an edge platform, but it's essentially a router. So I've got a very modern router here. I've also got another modern router here, an ISR 1100 4G, as well as these 1000 series routers. So I've got these two routers that have multiple Ethernet ports, and this one has a DSL port as an example. I've also got a Cisco firewall, as well as a Cisco LAN controller, and I've collected a whole bunch of access points so that I can physically demonstrate how things work. Now, what is a router? Routers basically route from one network to another. You may have a router similar to this at home. One of the most confusing things about devices today is that they actually combine various features together. So even though this is a router, it actually acts like a Wi-Fi access point. In other words, you can connect to the router using Wi-Fi. Here's a dedicated Wi-Fi access point as an example. This isn't a router. It's simply an access point allowing you to connect to the network using a Wi-Fi device. So this acts like a Wi-Fi access point. It acts like a switch. So it has what are called LAN ports, but notice it also has a WAN port. These are local area network ports. Local area network is a network like in your home. It's local to where you are. Routers route from one network to another using the WAN or wide area network. So as an example, you could use Ethernet, like on this router. But here's a 5G router. This routes from your home to a 5G network. Here's a Starlink router, routes from your home network, as an example, to satellites and onto the internet. Here is a DSL connection. This routes from your home network. So perhaps you've got some devices connected to these ports at home, connects you via your telephone to the internet or wide area network. So a router will route you, for instance, from Ethernet, your local area network, or Wi-Fi to satellite, or from Ethernet, your LAN interface, or your local network to 5G or 4G. Or if you've got fiber at home, you might have an Ethernet port on your router that connects you to a modem or a device that your internet service provider or ISP gives you at home with a fiber connection. Again, I'm hoping that this is the most complete, the most practical, and most real-world CCNA course that you take, that you're not just learning about stuff from a theoretical point of view, that you're actually seeing what these are. These are SFPs. So we've got 10 gig SFPs here. We've got gig SFPs. Here's a 25 gig DAC cable or direct attach cable. And here we've got 100 gigabits per second QSFP 28. I don't want you to go out into the real world and only learn about stuff through slides or through pictures. I want you to actually see how things work, and not just old equipment, but very modern equipment as well. Now, for the labs, you could use Packet Tracer. This is a Cisco 4321 router, and the reason I purchased this router is because it's part of Packet Tracer. So in the labs, I will show you physically how things look, and then you'll be able to configure them. Packet Tracer is a fantastic simulator, but it doesn't simulate everything perfectly. 2950 switches are also part of Packet Tracer. But again, I've got very modern switches like the C9200CX, fantastic little switch. It's important that you understand the difference between a classic iOS switch as well as a iOS XE switch. So I've got both examples here so that you can see how iOS XE versus iOS works. Basically, iOS is the operating system that devices run. So think of this like running Windows or Mac OS. So you're running a Windows operating system on your PC. This device runs Cisco iOS. This device runs Cisco iOS XE. So you need to learn the commands that the operating system uses in the same way that you'd learn commands in Windows or Linux or Mac OS. And that gets to me talking about PCs that are part of the lab. I'm going to show you Mac OS. I'm going to show you Linux. I'm going to show you Windows. Physical laptops that are connected to the devices so that you understand how things actually work versus what simulated environments do. So as an example, if I had this MacBook connected to port 1 on the switch and this Windows computer connected to port 2 on the switch, if traffic was sent from the MacBook to the Windows computer, traffic would arrive on port 1 and only go out of port 2 because the switch would learn where the MAC addresses are of the devices in the topology. With a hub, however, if the MacBook was connected to port 1 again and the Windows computer was connected to port 2, if traffic was sent from the MacBook to the Windows computer, it would go out of every port except the port in which it arrived, because the hub is basically a dumb device. It doesn't understand where devices are in the topology. It doesn't learn MAC addresses. It simply repeats or floods the traffic out of all ports except the port in which it arrived. Hence, it's called a multi-port repeater. We don't really use hubs today, but the reason why it's important to know about them is you need to understand collisions in Ethernet networks. Wi-Fi, as an example, is a shared medium. So the bandwidth is shared between multiple devices in the same way that it is with a hub. I've used a lot of terminology now. Don't let it overwhelm you. We're going to talk about what this means and why it's important. I'm going to show you how these physically get inserted into switches such as these and how they're used with fiber cables as an example. Don't let the terminology worry you. If you struggle, just know that you're joining many of us who started initially and it felt like we were drinking from a fire hydrant because there's so much information. Just keep on trying to learn something new every day and you'll get it. Networking initially seems really complicated because of all the terminology. Some people have told me that they find it really abstract. It's difficult to imagine things or to conceptualize things. And hence me buying, once again, lots of physical devices and cables and options to show you how things actually work, both for the CCNA, but also for the real world. Big thing that I suggest you do is download Packet Tracer. It's free software that you can download from Cisco and you can practice. So in the labs, you could either use Cisco Packet Tracer or CML, Cisco Modeling Labs. But if you're new to this and you're struggling, get Cisco Packet Tracer and I'll show you in an upcoming video how to download that and install it and build your own networks using Cisco Packet Tracer. Once you've seen real devices working, you'll find it a lot easier to work with Cisco Packet Tracer and configure networks yourself.